Okay, hi there. Real quick explanation just to show that the math does work with this. This is a cheesy thing, but hang on there for a second. I'm in the middle of producing this, and I don't have all my user interface buttons programmed yet, but I'm manipulating numbers in the software, so I have to reprogram the chip as I make this explanation back and forth. Anyway, I'm just sitting here now, just started programming a chip that has my basic standards, and that is if I have an input signal, I simply want the output signal to be matched. Okay, I mean, just simple. It's a straight throughput thing. I use my servo driver here to kind of get things going, and you can see if I go into can you all see that? Let's see. Boy. All right. You can see my servos are working together and in unison. This one's the master, and that's the one that's gone through the processor. They have exactly the same throw on both sides of center. There's no center anomalies or anything. And the programmer's already set up where I can actually reverse it. If I press and hold one of these buttons and let go, I beg your pardon, that's non-reverse. Try this one. All right. So you can see the reverse now. So they're all I did was boot up the chip in a different mode, and now they're in reverse. But they have exactly the same gain. I'm going to go ahead and put this back in the normal mode real quick. Okay, in the normal mode, they work side by side and in unison. Now give me a second here. What I'm going to do is I'm going to reprogram the chip so that my slave endpoints are now going to be reduced. If I have a certain value for an endpoint, I'm actually going to make it a different value. So I'm going to shoot for a lot less gain. This is actually like a factor of 5, but it can be any number. It doesn't have to be any particular factor. This is capable of having basically, for all practical purposes, an infinite number of ranges. So anyway, let me go ahead and pop the chip on this real quick. Let me just change one number first. What I'm going to do is take the low value, and where I normally am shooting for 1 milliseconds, I'm going to shoot for 1.4. Now we know 1.5 is the center. 1.5 milliseconds is the center. This is 1,000, so we got 1.5 is the center, and I've got 1,000 on one end. I'm going to move it from 1.5, instead of the end being 1,000, I'm going to move it to 1,400. So there's going to be very little movement on one side and quite a bit on the other. But that's only because I'm just moving one side of this value. So give me a second here to look at my values. My hexadecimal is going to be 578. And let me go here. All right, let me compile this real quick. There it goes. I'm going to reboot this back up. And I want you to take a real close look at the servo here. All I did was change a data value, one single data value, and I recalculated new constants and recalculated a new output. Look carefully. You can see that the servo that's the slave is now responding to a new endpoint. So its gain has been significantly reduced. But it's linear. I mean, there's no growling anomalies, there's no skipped or stumbling of output data pulses. Still running at 50 frames per second. And to further demonstrate this a little bit more to what your question was on the RCGroups, I'm going to go ahead and change the high end. Instead of going to 2 milliseconds, I'm going to have it go to 1.6. So now what we're going to do is basically reduce the gain of the slave servo. This is the master, it's just coming straight off my servo driver. We're going to reduce this one by a factor of, I guess, 5 then, right? Yeah, if I'm going from 1,000 to 1,400, that's 1, 2, 3, 4. Yeah, so instead of having a 500 microsecond span, I'm going to take it down to 100 on both sides. Right now it's just on one side. You can see when this crosses over center, and we get full gain on one side, and then it's reduced. Give me a second here and change my high-end slave value. I want to change it to 1,600. Give me a new hex number to stick in here. Okay, here we go. We are programmed. Now the chip has, the center is going to be 1.5 milliseconds. The end will be, the high end will be 1.6 milliseconds, the low will be 1.4 milliseconds. So it's going to be very, very small, considering we're going to see my drive signal is large, but my output gain is very small. And let me drop my chip onto the proto board. Okay, I'm going to plug up my servo cycler as my driver. And let's take a closer look at the servos now. Alright, again, that's my master. This is just a direct feed off of my servo cycler. And this is the output from my microcontroller. And you can see I've reduced the drive by a factor of 5. Now, to give you one more example, to give me just one more second here, we'll put this together. I'm going to go back and I'm going to change the data set values to, I'm going to change the data set so that it mimics exactly 50%. So 50% of 500 is 250 on each side. So we take 1500 minus 250 gives us a new number. And we want to take the slave low to 4E2, 4E2, and we want to take my slave high value to 1750, which is 6D6. Okay, we're ready to burn that one. And there we go. We're done with that. We'll go ahead and move it back over to the proto board, and now we're going to see that the slave servo is going to move exactly 1/2 the value of the master. Plug in the servo cycler, start it up. Okay, that's my master, and this is my slave. Let's get this back in picture. Okay, that's my master, and that's my slave. Let me line up the servo arms where it kind of looks a little more realistic here, and go back into the. You can see I'm getting half the movement. This is my slave. This is the one that's been processed. I'm getting exactly half the movement of what would be. This is just straight off my servo cycler, so that's the master, and that's my slave. And I wish you lots of luck. I hope that you can find an analog solution. Getting an analog solution to this, for me, is harder because all I got to deal with is what's on the computer screen. I'm dealing with analog stuff, and I basically start experimenting with components because I'm not that good at analog math, and I'm just unable to calculate it in my head and build it the first time and have it work. With this, my experimentation of values is a computer, not individual analog components, so it allows me to develop in a different fashion that seems to be a little bit more refined, a little more accurate, a little more reproducible. That's key here, because I'm making this for production purposes. So, I wish you luck with that. See you later.